Hi guys. So I'm not in class today, so I made a video. I do want you guys to do this for your warm up. For the warm up for yesterday, I want you to put no school would be great for Tuesday if you guys could write no school. And then for today, I want you to find the volume of this figure. So I'm going to ask if you could pause the video and let them do their warm up. That would be great. And then once everybody is kind of done, like 2 or 3 minutes, then go ahead and turn the video back on. I would like to see you guys have your notebooks out. You should be taking notes for 913. So we've been talking about prisms. And so now today we're going to talk about cylinders. And we're still going to be combining volume and surface area. So we talked about with prisms how we could take it and dip it in paint. So we're going to kind of continue on with that today. So again, if you guys want to write down in your notes that this is lesson 913, I'm going to draw underneath of here. And you should label it as prisms and cylinders. So that's what you should be writing in your notes for today. All right, so this is my first picture. I would not draw this in your notes, but maybe if you guys want to label this as problem 928 in your notes, part A, we are going to draw a net. So I'm not worried about the graph paper, but I am going to ask you guys to draw the net. So I'm going to try and highlight where the faces are. So I actually took this first one. Maybe I'll do it in purple here. So I took this first one. So I'm going to draw this purple one here. And then I'm going to draw my lines here. So I'm going to be drawing on top of my words just because I'm going to run out of room, I think, at the bottom if I don't do that. Okay, so that's my purple one. Then I'm going to try and do another color just so you guys can kind of see which one I'm looking at. Then you guys, I'm going to attach this one on top. Okay, so I'm going to go ahead and draw it. So that would be this piece. Again, my picture is not good. I guess that's why they suggested graph paper, but I'm not really worried about the graph paper. That should be good enough. So you guys, this is 4 of these, right? So that's why I have 4 of these. Okay, then what I'm going to do is I'm going to draw another 4 on this side. Oh, it's not going to let me draw on that, huh? I'll draw it like this. So you guys, that would be the bottom. We can't see the bottom right now, but it would be the bottom of this one. So again, it would be another 4. If you guys can kind of see that. Okay, then I'm going to switch to this side, my blue, and then it would be to the other side. So now you guys, this, if I unfold it, if you think about it laying down, this is going to go this way, but I have 4 now again. So I'm going to go 1, 2, 3, 4. And then on the other side, if I draw this is also going to give me 4 and then split down the middle. So again, I know this looks a little crazy. Now, the next question says, is there more than one possible net? Well, I haven't finished my net. You guys, if I try to fold this up, this would not be the rectangular prism. So I need to figure out, where do I want my other flap? So I would say, yes, we could draw another net because it kind of depends on where you want to draw that last flap. So what the last flap that I'm going to draw is another purple. So you guys, the only thing I haven't done is that back side of that. So I'm going to draw another purple and I'm going to draw it over here. That's going to be my other purple one. So this would be one form of the net. You could also put this other purple side up by the red. We could put it up top by the red and fold it that way. So there's multiple ways to draw the net for us. Okay, I'm going to get rid of this net so we can talk about the surface area and the volume. So the surface area, you guys, again, is like if I were to color it. So why don't you guys take a second and try and find the surface area and the volume of this prism. So I'm going to give you guys just like a minute to try and figure out the surface area and the volume of this prism. That was probably more like 30 seconds. So I'm going to do this first part. So this would be 6. I'm doing the surface area. I'm sorry. I'm doing the surface area first. So I did 6, but then I would have the back side, right? So that'd be 2. And then this top, I have 4, 8, 12. So I'm going to add 12 times 2. And then I'm going to add this side, 4, and 4 is 8 times 2. So if I add all of those together, you guys should have gotten 52. And then the volume, you should just be able to count up your pieces. So if I count up all of those, I should get 24. Okay, so now let's say I take all the blocks away. So we had the rectangular prism and that was nice. But now what if it's a triangular prism? Okay, so I do want you guys to try and redraw this prism. So my people who like drawing in 3D figures, you're going to love drawing this in your notes. Those of you that don't like drawing 3D figures in your notes, just try your best. I would probably start with this triangle at the top and then draw 2 lines down, connect those, and then kind of draw these like dotted lines in the back to kind of help complete your 3D figure. And they say like the hidden edges are on the backside are dashed. And now, for right now, I just want to know, I want to find the surface area. So you could probably tell me the volume, right? We talked about volume the other day, but right now I just want to do the surface area. We're going to do volume on the next slide. So for my surface area, we are going to, if you guys can look, think about like, what are my surfaces? So in the rectangular prism, all of our surfaces were rectangles. But now you need to think that I don't have just rectangles. You guys, you can see this triangle here and this triangle down here. Now those triangles would be the same and those would be the bases. The bases would have to be the same. And if you think back to what is the area of a triangle, that would be base times height divided by 2. So my base would be 3. My height would be 4. I would divide that by 2. But really, I'm going to times by 2 because I have 2 bases. So those 2's would cancel, or you would have 6. 12 divided by 2, which is 6. And then 6 times 2, either way, that's got to be 12. Okay, so that's just the bases. So now what I need to do is I need to find the area of the rectangles. So if you guys could kind of imagine this back rectangle over here, that area is the 4 times the 9. So I'm going to add 4 times 9. I don't think that's too bad. Let me get a new color here. Let's do bright green. This is 3. And again, this is still 9, right? So I'm going to have 3 times 9, adding on to there. All right, this one is the tricky one. Let's try red, I guess. Oh, I guess I could do yellow or just yellow. Okay, now I have this one. You guys, what's this length? How do I find the length of that triangle? Hopefully you're talking out loud in class. Because I know it's 9 times something, right? So how do I find that? I hope you guys are saying Pythagorean theorem. How many of you remember your Pythagorean triples? If you remember your Pythagorean triples, you can go ahead and plug that number in. If you don't remember your Pythagorean triples, you're going to need to take 3 squared plus 4 squared and then equal that to, I'm going to call it x squared. I guess you could call it c squared. So you guys, if you remember, it should be 5. 9 plus 16. And then take the square root of that. There's the 5. So I have 9 times 5. So if you guys add all that up, 12 plus 4 times 9 plus 3 times 9 plus 9 times 5. My surface area should be 120. Hopefully you guys are trying some of these on your own. So you're not just like waiting for me. So if you guys want to keep working, that's totally fine. I know it's hard to like kind of look ahead in here. Now I want to talk about the volume. So we talked about volume the other day. So I'm going to give you guys like 30 seconds to see if you can figure out what the volume is without me kind of telling you what it is. And then I'll talk about it. So go ahead and try and find the volume of this triangular prism. was my timer going off telling me to make this video. So to find the area of a rectangular prism, we found that base, if you guys remember, I'm sorry, the volume. Remember when we stacked it up? So we found the volume of the bottom. We found that area, right? However many there were. And then we just like stacked it up. So we talked about finding the area of the base times the height. So this base, if I find the area, we already did that, right? 3 times 4 divided by 2. So this area is going to be 6. And then I need to times it by the height. Because again, if you guys think about it, I'm taking 6 and I'm stacking them. I'm stacking 9 of them on top of each other. So that's why we times it by 9. So that total is going to give me 54. And really, I should put units on this, centimeters cubed. Up at the top for area, I should have put centimeters squared for that one. Okay, so now the next question is asking, does your method for finding surface area and volume of other prisms, does that work? And it should be yes, it should. So what I would like you to do is I would like you to pause this video. I'm going to scroll this up just a little bit. And I want you guys to try and find the surface area and the volume of this hexagonal prism. So you need to think back. If you need to talk in your groups, that's fine. So let's maybe take 5 minutes now. Let's pause the video, try and find the area of the hexagon, and then use that to find the surface area and the volume. One thing I do want to talk about quick before you pause the video is for the surface area, remember that this height is going to be 7. And then this base is going to be 4, and it's going to be 4 all the way around. So when you're finding the surface area, think about how many of those rectangles am I trying to find? So go ahead and pause it and then turn it back on and you can watch me walk through it. So with the hexagon, remember we take 360 divided by 6, and then we divide that in half. Remember, because my hexagon would be 6 sides. So this triangle, which if we think about it in here, that would be my triangle down there. That would be 30. I guess that kind of looks like a 50. Sorry. That should be 30. So this should be 4. I would use my 30, 60, 90s. I don't really want to use sine, cosine, or tangent. I guess if you guys wanted to use tangent, that's fine. A lot of you guys in your homework, you're forgetting this would have to be 4 divided by tangent of 30 to find h. So the h, you guys, in this triangle would really be 4 radical 3. So if you guys remember your 30, 60, 90, because the h is across from the 60. So either way, the height of this triangle would be 4 radical 3. So depending on when you round, we might have slightly different answers. Oh no, I'm sorry, I messed that up. This is not 4 radical 3. Okay, so for my hexagon, when I draw that, this is the triangle down here. This should be 30, and this side shouldn't be 4, it should be 2. So if you remember your 30, 60, 90s, that would be 60 degrees. So across from the 60 would be the height. So this would be 2 radical 3. So that would be my height. And then if I times it by my base, and again, I'm thinking back to that bigger triangle in the hexagon. So I would take 2 radical 3 times the 4 and then divide by 2, which some of you guys are probably already taking 2 radical 3 like times 2, because you're just using that regular 2 knowing that. So if I reduce this, this would be 4 radical 3, but that would just give me one of these. So I have 6 of those, so I have to times it by 6. So if I wanted the area of that bottom, it would be 24 radical 3. And I'm going to need that for the volume and for the surface area. So if you guys think about it, for my volume, I'm going to go to a different color. If I'm trying to find the volume, I'm going to take 24 radical 3 and I'm going to times it by 7, right? The area of the base, and how many of those? There's 7 of those. So I would just take 24 times 7, and we could leave this as 168 radical 3, or we could write it as a decimal. So if I write it as a decimal, it would be 290.98. So this would be the volume inches cubed, I should say. That would be my volume. So now if I'm going to do surface area, I have two surfaces of 24 radical 3. So I can times this by 2. And then I'm going to add, you guys, if you remember my rectangles here, so this would be 4 by 7. So think, how many rectangles do I have that are 4 times 7? Hopefully you're saying 6. So I'm going to have 4 times 7 times 6. And that's going to be my other surfaces for that. So that's going to be 168. And then this would be 48 radical 3. And then I'm going to go ahead and at the end, write it as a decimal. So I took 168 plus 48 radical 3. So that should be about 251. So 251.14. And I guess I should write inches squared. You guys, if at any point this is going too fast, you can always ask to pause, or it's also going to be posted on Canvas. So if you want to go home tonight and you need to like fill in any gaps or anything, you can always go on and watch the video there as well. I just can't have all of you guys in the classroom streaming the video at the same time. So we found the surface area and the volume for the hexagonal prism. It's a similar process, just a different formula for the area. We talked about the other day, what other 3D shapes do we have? And somebody said cylinders. So now we're going to talk about cylinders next. I want you guys to try and copy this cylinder on your notes for today. So again, try your best, like draw a circle at the top, draw the 2 lines down, and then draw a little curve. And then I want you to think about how to find the surface area and the volume, given that the radius is 5 and the height is 8. So I'm going to start with volume. To find the volume, just like our other prisms, we find the area of the base and we times it by the height. So we're going to find the area of the base, which is 5 squared pi. So I'm going to change that to 25 pi. And then I'm going to times that times my height. So if I do that, that's going to give me 200 pi. That's going to give me 200 pi. And you guys, I'm just going to leave it in terms of pi. I guess if you wanted to, we could turn it into a decimal, which if you wanted the decimal, it would be 628.32. And it just says unit, so I guess I could do units cubed. So we could do either one of these as the answer. And now if I wanted to do the surface area, so the surfaces, the top and the bottom, those would be circles. So I'm going to have 25 pi. Do you guys see how I kind of cut to that right away? So this part would be 25 pi because we found that over here. And I'm going to have 2 of those. So that's going to give me 50 pi. But now you guys think about like, wait, what is this other part, right? Like what's the part that I didn't color in green? So what I want to do, you guys, is I just want to show you the net of this. And I think that might make a little bit more sense. So if you think you have an idea on how to find this other area, you need to find another piece because we don't have this surface around on our surface area yet. So if you guys think about a net for a cylinder, the net would look something like this. Again, there's a couple of different ways you could draw it. But essentially, when I unwrap this, if I cut it, that's going to be a rectangle. So the rectangle, the height, is going to be this 8. I know it doesn't look exactly to scale or anything, but that's going to be the 8. So now I want you to think, what would be this part here? Because if it's a rectangle, I'm just taking the base times the height. So I'm going to have 8 times, think about what is this length? What is that? I hope you're saying circumference. That would be the circumference of this circle. This length here would go all the way around. It would wrap around that circle. So that's going to be the circumference. So the circumference is 2 times pi times r. So I'm going to have 5 times 2, which is 10, and then times pi. So I'm going to go ahead and change that to 80 pi. And again, I got the 8 from the height of that cylinder. So then 50 pi plus 80 pi is 130 pi. So that could be one answer. Or if I wanted to write it as a decimal, my decimal would be 408.41. I want you guys to change that 0 to a 1. And again, this would be units squared. So this is really good practice for us. I want you guys to copy these math notes. I will post them on Canvas for you guys to take a screenshot. So if you guys at home or you guys in the classroom, when you get some work time, I want you to take a screenshot of this. The one thing I want to talk about quick with this math notes is this thing called Cavalieri's principle. And essentially what's that saying is like, if we have a cylinder and if it's tilted to the side, then it's going to have the exact same volume. So if it has the same height and it has the same area of the base, it would be the same even if it's shifted to the side. Okay, so that's this Cavalieri's principle if you guys ever look it up. And then the last thing is you guys do have homework. And so I want you to do these 4 problems for homework. These are already listed on Canvas and they're all set for you. So those of you in the classroom, the remainder of the class period, I want you to be working on your homework. I did update your homework yesterday. So I need you to make sure that if you have missing homework that you go in and submit those as well. If you have questions, feel free to send me an email. I probably will not, I don't know when I'll be able to get back to you. But if there's issues with things on Canvas and stuff, just send me an email and I'll try and fix it as soon as I can. Okay, please make sure you behave for the sub and I will see you tomorrow.